So we've made it past the first hurdle now, which is installation. But what happens when we actually try and use redo? Welcome back to episode 14 of Haskell from Scratch. It's about time that I addressed something that I've been seeing in comments since the very first few episodes, and that is Windows compatibility. I was tempted to address this by saying that really the design for redo was made for Unix or Posix systems, but I don't like giving up before even giving it a try, so let's take this episode to see how far we can get. This install.do file is symptomatic of the assumptions I've made about redo running on a Unix system. So I think the first step before even switching to a Windows system for testing is relying on the fact that Cabal install is already cross-platform and use that for installation rather than trying to roll our own. Maybe in the future we can have distribution packages and Windows installers, but for now I think even getting it to the point where someone could Cabal install this would be an improvement. So Cabal already takes care of tracking changes to the source. It's already going to install redo to someplace presumably in the user's path if they set up Cabal install correctly. The only thing that it's not doing right now is setting up a symbolic link to redo if change. Fortunately, Cabal has some hooks that we can use, and we can change the standard setup.hs that was generated for us to essentially do anything we want with Haskell code. You can take a look at the Cabal library documentation to see what these hooks are, but I'm not going to go into too much detail on it because the documentation says that they're in flux and you shouldn't rely on them being stable. So my first step is going to be finding out the directory that Cabal is installing to so that we can use it for doing some symbolic linking. So here's the code that I've come up with, and don't worry about the details. This is very Cabal specific. It's prone to change, and I don't even think that it's the most correct way to do this. I ran into an error trying to use some code from the default install hook, but this seems to do the job. Now to actually use this, we need to change the Cabal file from a simple build type to a custom build type. And I added a print statement in here so that we can see which directory things are going to be dropped into. So let's run cabal dev install. So what Cabal has done here is taken our custom setup.hs and used it to build a setup program that will then build and install our redo executable. And here on the second to last line of output is that directory name that I grabbed. So using this, we should be able to make a symlink on install. We can import create symbolic link from system.posix.files, and then instead of printing the dir, we can create a symbolic link from the redo binary in the dir to a link in the same directory, redo if change. So let's compile that and see what we get. And so now, if everything worked correctly in the cabal dev bin directory, we should have redo if change. Don't mind the redo if create symbolic link. That was from me testing some things earlier. Just in case the timestamps aren't enough to convince you, let's run this one more time. And there they are. Now these got installed to the cabal dev bin directory just because I'm using cabal dev, but if you were using cabal install, they'd end up in, for example, on Linux, in .cabal bin, which presumably is in your path. So that wasn't too bad. I'm going to go ahead and commit these changes and then check them out on a Windows machine, and we'll go from there. Okay, so here we are on a Windows machine, and all I've done is checked out the code, installed the Haskell platform here, And then I installed Cabal install and Cabal dev. I hope you'll forgive my general ignorance on Windows. The last time that I used it was about 15 years ago. So I'm just figuring this out as I go. So let's start by seeing what happens when we run Cabal dev install. Well, we hit a hitch here that system.posix.files was not found, and I guess that's to be expected since Windows isn't a POSIX system. One thing that we can do is use conditional statements to change from using system.posix.files to a Windows equivalent. To do that, first you need to enable a language extension, the C preprocessor. So language CPP. And then I looked through some of the core libraries source code to see what was the way that they checked for Windows in there. So it's if defined min-g win32 host OS or defined min-g win32. Then we know that we're on Windows. We need to do something different here. Otherwise, we can run this import. Now, I looked through some of the Win32 libraries for Haskell looking for a create symbolic link alternative. And while they do exist, from what I understand, it works on certain versions of Windows and only if permissions are correct. So I'm going to take a little bit of, I guess, set up a hack here. And instead of creating a symbolic link on Windows, it's a little bit wasteful, but I think it's more robust to go ahead and just copy redo to redo if change. Now, I don't have FlyMake set up on Windows, so we're just going to have to test this manually. And it looks like I made an error. These should be end if. Let's try that again. And we need copy file from system.directory. And the flow here is the same. First, Cabal dev has built a setup.exe, but we run into a problem with the actual copying. And rather than relearn DOS right now, I'm just going to do what I know here. So my guess here based on the error message is that Cabal dev is messing up a little bit with that directory. So let's try, instead of Cabal dev, let's just use straight Cabal install. Cabal install. Of course, this makes sense here. I see it now. It's actually the exe that's missing on this. So let's edit the source and change this to redo.exe to redo if change.exe. Let's try that again and see what we get. So now there's no error messages, and since I already set Cabal, the Cabal bin directory in my path, we should be able to execute redo and redo if change. And it works as you'd expect. So we've made it past the first hurdle now, which is installation. But what happens when we actually try and use redo? We get this error that sh is not recognized as a command, which is what we expect because sh is a POSIX-born shell, which doesn't exist on Windows, at least not by default. So I sat around for a while thinking about this and researching POSIX shells and thought, wouldn't it be great if, similarly to how we have redo behave differently, if it's called as redo if change, we had some sort of shell implementation in the redo binary that could handle things. And this would have the benefit that even on systems that aren't Windows, you could be reasonably assured that you're actually running a POSIX shell and it would be compatible on the different platforms. For instance, you'd have less of a problem introducing bash syntax in your do scripts on systems that just link bash to sh. But even as appealing as it is, to find some way to either implement a shell implementation in Haskell or somehow link against a C implementation that still only handles the shell command, what do you do about the other commands in the file, for example, mv? So after a little bit more research, I came across a version of BusyBox compiled for Windows. And I thought, right, well, that's a good first step. Let's see if we can get a shell running. So here, inside of the redo directory, I've downloaded a copy of that BusyBox executable, and let's see what we can do with it. So let's just try running BusyBox, and fortunately, or unfortunately, depending on your philosophy, the current directory is in the path on Windows. So if we want a shell, we can say BusyBox HS, and that gives us a born Posix shell, and I'll use Control-D to exit. It also comes with a number of other commands like ls and so on. Now what we could do is do some more conditional compilation in the redo.hs file so that instead of calling our command, let's see, where is it here, sh-e, we could on Windows use BusyBox in front. But there's a better way, and this is how it's done usually on embedded Linux systems. We can rename BusyBox to the command that we want to run, and BusyBox, just like our redo if change program, will detect which program it's running as based on its name. Now, can we still do ls? No. So at this point, I was thinking about symbolically linking BusyBox to all of these different executable names, but based on what I've already seen, I don't want to try to rely on symbolic links on Windows, and copying BusyBox to all these different file names would just be too much of a waste of space. But as it turns out, if BusyBox is executed as sh and asked to interpret a shell script, it automatically redirects the programs for you. And note here that move ran, even though it ran into an error because it doesn't have the .exe on it, it did manage to actually get to this point and run the move command. And conceivably we could fix this by, instead of just using the file here, we could look for it on the shell. Something like this. This would have a problem with catching the redo if change. But the point isn't to fix this redo script itself, since we're getting rid of it for Cabal install anyway. The point is to show off that any BusyBox command should work from inside of our script. So if we want to print out the MD5 checksum of the redo.hs file in our redo script, we could do it here, but remember we need to send this to standard error. So let's try that again. And there's the MD5 checksum. So it turns out that it was surprisingly easy to get redo running on Windows, even though I haven't yet fully tested everything. The only change we made to the source was in the setup.hs, and that was really just changing one line and an import. There were no changes to the main source file. One other thing that we could do is, instead of relying on the maintainer of a project to add the BusyBox binary into the directory, we could download it and place it in the Cabal bin directory. After all, we have full access to the Haskell runtime here. We can use the network and do things like that, but I think it's overstepping the boundaries a little bit. And I suspect that the author of do files is going to have to make a conscious decision to make the scripts compatible with Windows anyway. So it's probably better to have redo scripts fail on Windows by default. Now, I'm by no means making the claim that redo is ready for Windows, ready to be used as a production build system. I really haven't tested it that much beyond some basics. So if you're using Windows and you want to use redo in a project of yours and run into any problems, just open an issue on the GitHub repository and I'll do my best to help diagnose and fix it with you. Thanks for watching, and I'll see you next time.